Hi children, this is your ICT sir. Welcome back. Today we are going to learn Scratch for grade 9 students, and I hope you can remember about all the control structures that I have taught you previously. And we are going to learn the chapter 3 today, programming. After completing this lesson, you will be able to understand what are multi-conditions, use of flowcharts and how they are solved with many conditions, repetitions, use of flowcharts to solve problems, developing a program, a Scratch program, finally to represent a useful program for the children to begin understanding about the concept of programming. So you can download the Scratch program from the following website, and then looking at this picture, you see the father is talking to the son. So he says games are not bad, but it is better to develop your own game. I love computer games, the son replies. So how can I do? The son replies. There are enough softwares available to develop computer games. You will get a chance to improve your knowledge while having an opportunity for playing. Alright? So today, games, it is not about a game actually, a program. When you try to develop a program, you got to know what are its basic needs and what are its inputs, outputs and process, and make decisions according to a given condition and so forth. Here a simple program illustrates if you toss a coin, if it falls, the head is shown, else the tail is shown. Very simple. Let's go to, it is a simple selection. There is nothing much to say about it. Very simple selection. Selects either the true or the false. Here you find that the dice is tossed within certain values of 1 to 6. If the tossing dice fails the value of 1, it should show me 1, 2, 3, 4, 5, and at the end, if it does not show 6, at the end you can get 6 as it is. So we are going to learn about how simple selections can really help you. Control structures with repetitions. As you see, there is a train, a toy train keeps moving around its rails as long as it has its battery, as long as it has its electricity. It will keep on moving until it meets its condition. So over here, the repetitions is about action getting repeated again and again. It is displaying repeatedly. So over here there is an example shown here. example of displaying numbers 1 to 5. So here it begins. The number is initialed. It is given an initial value of 1. And then is the number lesser than 5? If it's yes, show the number and then add another number, increment a number by another 1 value, and keeps on asking the question whether it is lesser than 5. Once it says no, then the program executes. So by now you should know how many times it loops. 1, 2, 5 times it loops. So it's a loop condition. Looking at this scenario, the pump works according to a given level. Is the tank full? If it's yes, instructions are to stop the pump. Else, if it's not filled, the water flows into the tank until it reaches the level of stopping the pump. So this is also some kind of a repetition. Calling out the students. When when your teacher calls you, you say you are present or you are absent. So when the student is called, is the student present? If it's yes, it's marks as present or absent. And then teacher keeps on asking for the names, and then it ends. Once the children are, if there is 40 in a class, if the 40 children are called, then she can stop her work and the process ends. Now in Scratch we have some palettes or some tabs that can really do the repetition and repeat until. We will look into these things within another little time. And forever, you get forever, repeat until a condition is met, so forth. So developing a visual program involves repetition. For example, this example shows you children, when you are trying to develop a program of trying to get the multiples of the given number, for example, if you enter 2, what are the multiples of 12? 12. First 12 multiples are, if so, you can get 2, 4, 6, 8, so forth. And if you add 3, what do you get out of 12 multiples in 3 when you multiply them? So you get 3 times and the 12 times. And then if you want to design that in a flowchart, here you are. Begin, get number. The number of times equals 1. It is initially given 1. Numbers of 12 times loop. It's going to loop until the number of times is equal, lesser or equal to 12. And then it keeps on multiplying it. Multiply the number by the given number. For instance, 2 is multiplied by 2. So it's 4. So show the multiples, and then it keeps on adding the first number and the second number, the third number, until the number is lesser or equal to 12. And then once it is equal or lesser to 12, then it ends. So number of times repeated is 12 times. So this is illustrated in the Scratch program. So we can see them step by step how you can develop that. There's another number displaying random numbers of 1 to 100, an infinite number of times, generating a random number from 1 to 10, and it displays is the number greater than 0. If it's yes, again it keeps on displaying the number, and then once if the number is greater than 0, if it's no, then it ends. So you get a random values taken from 1 to 100. It depends. The computer generates from 1 to 10, 1 to 100. So any value that is given a condition is the number greater than 0. If it's yes, it keeps on looping infinitely. When you look at this example number 2, I hope you have played the Ludo game. So it starts from first and reaches up to this as 36. You get 400 also, both. So whenever the dice is tossed, the number that is shown in the dice, it increments. So anytime the die, you can increment its values. The moment if it reaches the 5th, you can go up to the 7. It reaches to the 7. And if you happen to come to number 12, then suddenly you see that you go down the snake and comes to its second value, and then you got to go back again. So it's a nice game. How do you do that in a flowchart? It shows here: begin, toss the dice, get the value, take the counter forward by numbers of squares equivalent to the dice value. For instance, if you got 6, so you go according to the squares 6 times. So reach. Now while you are doing so, there is a condition asked: did you reach the bottom of the ladder? If it's yes, take the counter to the top of the ladder. No, reach the square with the cobra's head. If you have reached there, if it's yes, take your counter way down where you can see the end of the tail. And then if it's no, if these two have not done, is the number of square equal to 36? Have you reached 36? If you have reached 36, then the game is over. If not, you keep on playing it, and then you toss it again and go over and over again until it reaches its condition, and the game is over. It's easy, isn't it? Right. So you can construct that in Scratch, and then you come down programming with array. Now, array is something like like this. When it comes to computer programming, each values are given a variable. For instance, I need to just assign A and I give its value equal to 10. So now the computer's memory knows that there is a value of 10 in a variable called A. But there is only one value you can assign to the memory of the computer. But if you were to assign A equals to, let's say, 10, 20, 30, 40, so on, then you use something called array, something known as array. So arrays, now you can say like this: children who are in grade 9 are an array, a set of arrays. So grade 9A, grade 9B, they are a set of arrays associated, and their names given and the values are given separately. So for example, name of a variable can be marks, marks 1, marks 2, so forth. So marks 1 can have a value of 7. So when you are assigning an array, you have to determine when does the array begin and what time does the array ends. So array mark 1, 1 to 30. You might have 1 to 30, a value of 30 numbers. So you cannot exceed more than the 30 if you have assigned only to 30. So you should remember. In a class, if the teacher can only occupy 40 students, then you can't add another one more student to your class, because it's full. So arrays are like that. Alright, so I hope I will teach you how to make an arrays also, and then we'll see how these things works. Here you are. There is an example of two arrays given here: name and marks. Name is a common array, and it has how many values? 5 values. Marks is an array, and it has 2. The length of the array is 5. So you should remember the length of the array determined by the user, the program. So learning about arrays, you can make programs. And over here there is a simple program. When it is clicked, repeat 10 times, ask the number and wait for a little while. Add the number to add answer, the answer that is given here. For instance, if I add 10, 10 is added to the answer, and that is equal to the number. So it keeps on asking you for 10 times, repeating. So enough talking, let's move on to some real thrilling programming in Scratch. So when you open Scratch, the interface looks like this. I hope you can remember. it is divided into 3 sections. The middle section is where your codings are added, or on your left side you find the common use blocks, starting with motion, going down towards my blocks. These blocks contain all your scripts that are necessary for you to make a program to work. Instructions, they are like instructions. And over here you find where you put all your instructions in it. Over here you will find the background of your sprite and what the background does. Actions are taken place here. And down under you find sprites. You can use many sprites as you wish. Just choose a sprite and the sprites can be taken. And then the backgrounds, whatever the backgrounds that you really like, you can add it. So I'm not really quite worried about the sprites and the backgrounds. I really want your children to learn about how loops, how selections, and how repetitions, and how sequence are worked. There are 3 control structures: sequence, selections, and repetitions. Let's learn them step by step. Right, I have made a very simple sequence starting from the beginning way down to the end. Doesn't have so much there. So Abby is over here asking you some questions, and according to the answer she greets me. Let's run this program for a little while and see. Hello, what is your name? Right, let me say Amachula and click OK. Hey, I'm Amachula. Nice to meet you. See you. And the program ends. This is known as, in your control structures, this is known as simple sequence or sequence, starting from the top and ending it from the bottom. Very simple. It does not have any decisions taken, so it's just simply runs. Let's move on to the selections. Right children, this example, Abby is asking a question from you. She greets you, say hello, and ask you a question. What did you bring for lunch? And if your answer is rice, she says, let's eat now. If you say, let's say nothing, then she says, let's buy something from the canteen. And the program ends. Let's run this and see now. She greets you. Let's say rice. And click yes. Well, let's eat now. And if I say over here nothing, because I'm not saying, because only if it's rice only she will like to eat. Then only she says she can eat with you. If not, let's buy something. Let's say nothing. Let's buy something from the canteen. And then the program ends. I hope you understood this. To this I have taken a condition with if and else. This is known as a selection. Either it's true or else it's false. You can do a different statement. There are two statements here. Let's eat or let's buy from the canteen. Now this program, I have just only added repeat 10 times. So 10 times I will ask, let's see, hello, what did you bring for lunch? Let's say rice. Well, let's eat. And it keeps on waiting for 10 times. So you must remember this loop will go on. Let's eat, let's eat, let's eat for 10 times, and then it stops. And then it stops. Do you see that it stops? Again, if you ask, what did you bring for lunch? Let's say nothing. Let's buy something from the canteen, and it's still going on, and the program ends. Let's buy something from the canteen. The program ends again and keeps on doing it until the condition is trying to get it true. So do you see that it keeps on? So how many times did it loop now? So by the time when this video is recorded, is over, it will stop. So let's stop this. Now children, in this scenario, there are two loops that I'm going to show you. One is repeat a until it is greater than 10, and then increment, say a how much, wait for 1 second and increment, change a by 1. So if it was 1, now it will be 2. So forth, it will loop until it is greater than 10. So let's run this and see how many times will it. So 10 times it looped. 10 times it looped. So in this, if you see, let's run this, equal to 10. Right. How many times did it loop? 9 times, and the value is now equal to 10. So 9 times. So I just made a simple scenario here. Example, I have initial a equals 1, loop until a is greater than 1. Add a, the value of a, previous 1 plus 1 becomes 2. The first loop, it is 2, 3, 4, 5, 6, 7, 8, 9. Still it is not greater than 10. 10 is not greater than 10. 11, it stops. So how many times if you count? 1, 2, 4, 5, 6, 7, 8, 9, 10 times it has looped. This is an example of repeat loop. I hope you understood. As it's shown here. Right children, now if you want to draw a flow chart for the following scenario, for the first scenario, you can use it this way. Begin. A is initialized to 1. Is A lesser than 10? If it's yes, display A, and then increment A by 1 and keep asking the question whether the A is lesser than 10. Once if it's no, then it ends the loop. So my children, there are a lot to learn. Let's see whether we can do some more with loops and construct programs using loops and selections and repetitions and so forth. Children, now you can use the second method. I use the first method, lesser than 10 or is A greater than 10. You can shift this yes and no in between and make very simple charts. The lesson is over today, so I will give you some very simple basic flow charts and how to design them in the next lesson. Thank you for learning. Goodbye for now.